to radians and radians to degrees. Today we're going to look at converting degrees to radians and then also back the other way, radians to degrees. All right, we've been using degrees for a long time throughout high school math and even before. Degrees is a measurement of an angle. All right, radians is a different way of measuring angles that's specifically based around the concept of pi, which is used dealing with circles. So think of radians as another way of measuring an angle created by rotating a line around a circle. All right, a couple little concepts that are important is that number one, if I'm writing an exact value of a radian, my answer has the pi symbol in it. All right, if you type in the pi symbol. So we're going to look at some situations, and I'll explain when we look at the examples a little bit differently. But my exact value of radians has a pi, all right? If you are trying to write something as a radian and you just type it in as a decimal and you don't have a pi in there, then that is not the exact value, and therefore it would not be technically correct. All right? Now, one measurement of radians that's important, which actually generates how we convert from degrees to radians, is the fact that 180 degrees, or half a circle, is the measurement in degree of a half circle. Pi is the measurement of a half circle in radians. So these two are the same angle, but they are different measures of each. 180 is degrees, pi is the number of radians. This is what I'm going to use to convert from degrees to radians and then radians to degrees. Okay? So let's look at example number one. Example number one is 45 degrees. I want to convert 45 degrees to radians. So my first examples are going 2 radians. Now, in my opinion, 2 radians is pretty simple. I'll show you a shortcut or explain to you a shortcut that actually makes it a little bit quicker. So 45 degrees, I'm converting to radians. I'm going to use I'm going to use this symbol and 180 degrees to help me do that. If I want to convert 2 radians, I'm going to multiply by pi over 180. This is the ratio of a half circle in radians to a half circle in degrees. And if I solve this, this will give me 45 degrees in radians. Now, here's a hint, okay? I want my answer to have a pi in it. If I type this in the calculator with the symbol pi in it, it'll give me a decimal. So I don't want to do that. So what I'm going to do is I'm going to simplify 45 over 180. I'm only simplifying the numbers and leaving the pi on top. So 45 over 180 simplifies to 1/4 pi. So 1 times pi is pi, and the 4 stays on the bottom. So 45 degrees is pi over 4. All right? My next example is going to be done the exact same way. Example 2, I'm doing 260 degrees, 260 degrees. All right, so once again, I'm going to multiply by pi over 180. I'm going to simplify 260 over 180. When I simplify 260 over 180, that gives me 13 over 9 times pi, which is 13 pi over 9. Now, the way I can do this in the calculator is I can type in 260 divided by 180, math enter, and it will simplify my fraction for me. All right, same thing can happen on Desmos. You do 260 divided by 180 and hit that little math symbol on the left side, and it'll simplify it for you. And as always, there's a pi on the top of the fraction. The pi always goes on top of the fraction when I'm doing degrees to radians. All right? Let's look at 2 more examples. So example 3, I have negative 70 degrees. In relationship to a circle, I can have negative values for measurements because that just has to do with which direction I rotate around the circle. So if it's a positive, I'm rotating counterclockwise. Negative would be a clockwise rotation. But from here, I just do the same thing. If the degree measurement is negative, then the radian measurement is going to be negative. So I can multiply by pi over 180, which also can be written as negative 70 over 180 times pi. I'm going to simplify the negative 70 over 180, which simplifies to negative 7 over 18. So this is negative 7 pi over 18. All right. Example 4 is just more of the same. So notice when I'm converting from degrees to radians, it's just the same thing every time. In this case, I want to convert 415 degrees. I multiply it by pi over 180. I can write it as 415 over 180 times pi. Simplify 415 over 180, which simplifies to 83 over 36, and the pi is still there on top. All right, so that's converting from degrees to radians. And notice each time I multiplied by pi over 180 because I want the pi to be on top of the fraction. If you combine my money with Bill Gates' money together, we have approximately $80 billion. Now we're going to look at converting radians to degrees. It's very similar to converting degrees to radians. The only difference is now we want that pi to go away and to leave me with just numbers. So instead of multiplying by pi over 180, now we're going to multiply by its reciprocal. So going from degrees to radians, we multiplied by pi over 180. To go from radians to degrees, I'm going to multiply by 180 over pi. Now, the nice thing about this is, by all means, go ahead and type everything in the calculator, okay? I can write 2 pi over 3 times 180 over pi. It'll cancel the pi's out for me. It'll multiply straight across, which gives me 360 divided by 3, all right, which is 120 degrees. So 2 pi over 3 is the equivalent of 120 degrees. All right, so notice my pi's cancel out, give me 2 times 180, which is 360, divided by 3, gives me 120. Also, you can just type in your calculator and it'll cancel the pi's out for you and leave you with 120. All right, example number 2. Same concept, this time it's 3 pi. All right, once again, I multiply by 180 over pi. Notice that if my original has a pi, I need it to go away, so I'm going to divide by pi. That's how I know my pi should be on the bottom for 180 over pi. So my pi's cancel, giving me 3 times 180, which is 540 degrees. Example 3, more of the same stuff. 13 pi over 4 times 180 over pi. Pi's cancel. I have 13 times 180 divided by 4, which equaled 585 degrees. For the last example, example 4, negative 11 pi over 2. So once again, there's nothing that says my measurement can't be negative. That just reflects on the direction of rotating the line around the circle to give me my angle. So once again, I multiply by 180 over pi. Pi's cancel. I have 11 times 180 over 2. Sorry, negative 11 over 180 times 2, which gives me negative 990 degrees. So just pay attention about whether the pi goes on top versus the bottom in terms of whether I'm converting to radians or degrees, but it's just pretty much the same thing over and over again. Shouldn't be too bad.